Good afternoon. Am I on? All right, well, thank you all for hanging in there through the afternoon of the second day. I was kind of expecting this was maybe going to look like a Friday morning, 8 a.m. class that I used to teach at the university, but this is great. And thanks, Leaf and Morgan, for putting this on. Great facility, great presentations. So I feel honored to be able to come and visit from Colorado for a couple of days. It's beautiful. And just have a few things I'd like to share with you today about, mostly regional stormwater planning and a few other low-impact development topics. The other topics I'm going to talk about, and these are kind of in the order of length and sort of level of detail, a full spectrum detention, which I'll get into, but it's basically a detention basin design technique that we have found is very effective at reducing some of the erosion problems that we've learned about earlier this week. And then, of course, the more traditional definition of low-impact development, a lot of us start to think about just green infrastructure. We've seen plenty of presentations on these. We do have a lot of experience working with that, and so I'll just kind of finish up with a few lessons learned on, that myself personally and Wright water engineers have found over the years working with green infrastructure. And then we'll see if we have some time for Q&A. So I do work for Wright water engineers. The reason I am here is because I'm really standing on the shoulders of giants that have been working in Northwest Arkansas for a number of years. We're approximately 50 employees in 3 different offices, Denver being our main one. We're also in Glenwood Springs and Durango, for any of you that are interested in, working for us and moving out to a mountain town. Those options are available. And like I said, we've been involved probably over the last, 30 years or so, not myself, obviously, but some others, working on a variety of projects from criteria manuals. We saw a little bit about the Cave Springs Recharge Project. We were involved with that. Master plans, permitting, wastewater, stormwater, phosphorus analysis, et cetera. And Wright Water, we really were kind of founded as an urban drainage and water rights to a certain extent, but an urban drainage firm back in the 60s. And that has really led over the years to a lot of our folks being sort of national leaders in stormwater practice, developing manuals of practice and modeling and things like that. So this is definitely sort of our forte here, these type of conferences. I am going to mention the Mile High Flood District because the main topic here today is regional stormwater planning. And the Mile High Flood District, formerly known as the Urban Drainage and Flood Control District, is sort of the regional stormwater entity in the Denver metro area. And I couldn't possibly do this presentation without mentioning them because not only are we working within the jurisdiction of the Mile High Flood District, but we also work hand in hand with them. Our offices are right next door to each other. We literally kind of serve as an extension of their staff on a lot of projects. So I'm here talking from a Wright water engineer's employee perspective, but also in a way kind of representing a lot of what Mile High Flood District has done over the years and continues to do today. Just a few statistics you can tell here. 1,600 square miles is the area that they cover. 1,600 miles of major drainage ways. They're responsible for master planning, regional construction, maintenance of stormwater facilities, a lot of research into stormwater. I'll talk about that a little bit towards the end. They're also, pretty well funded. They got another mill levy passed a couple of years ago, so last year's funding was $66 million, so they can do a lot. So, again, just kind of start off, put things in perspective. I always like to do this whenever I'm traveling somewhere because rainfall is different and runoff is different. So these are just some, kind of quick, rough numbers. This is, annual precipitation around here. The different storm events, I'm going to be talking about the 2-year, the 10-year, the 100-year storm event. So you're looking at roughly 4 inches of rainfall, 5 inches or 8 inches of rainfall. And what does that mean in terms of runoff? Again, these are rough numbers back of the envelope. But for converting 1 acre of undeveloped land in northwest Arkansas, and we just kind of did like a low density, sort of like a typical large estate, 1 acre, single family home type of development, considered low density, to high density, maybe 95% impervious, something like that. But you can kind of get to see what that results in terms of additional water in the streams. Annually, you're looking at about, 250,000 gallons of additional water in the stream, up to 600,000 gallons for a high density. And that's 1 acre. Maybe about, what's the inside of this hangar? Maybe a half acre, something like that, maybe a third. So kind of put that into perspective, Olympic swimming pool is about a little over 600,000 gallons. So if you take 1 acre of farmland, you put an apartment lot to lot on it, you're going to result in an Olympic swimming pool worth of additional water going down the stream each year. So, regional stormwater planning. I want you to kind of look at this map. You can see here, this is a map of all the drainage ways in the Denver area. And, kind of pick one of the tributaries, for example, and just kind of focus in on it for a second. And now look at it and see how many boundaries that tributary crosses that wasn't there before. You're hard to find one that's only within a single jurisdiction. That's not surprising. There's always somebody downstream. It's no different from what is happening around here. So we know this. Stormwater impacts don't follow governmental boundaries. The downstream communities suffer for the decisions and the development that occurs upstream if it's not done well and carefully. And so it just makes sense that everyone recognize they all suffer the consequences from somebody else upstream, and they also cause impacts downstream. So let's come together, kind of work together, let's acknowledge that, and start to figure out solutions. And I have this last bullet point here: low impact development is not no impact development. And I do think that's important to remember, because we can't just be thinking about solving the problems that exist right now. Development is going to continue to occur. And even if we can do low impact development, it's still going to have an impact, and there's still going to be things that we need to think about and mitigate into the future. So we're not just solving today's problems, we also have to predict and think ahead to solving our future problems. I think the goals of stormwater planning, whether it's local or regionalized, right, it's simply, for the most part, a difference in scale. We want to protect, people and property against flooding and erosion and stormwater quality problems. Obviously, the regional part is that you're working with other organizations, other municipalities, and doing it in a cooperative manner. You'll see as I kind of go through this, the outcomes of stormwater planning are really capital improvement projects, plans to set aside and preserve space for stream corridors, regional detention, for example. It helps developers understand what they need to adhere to in their development. I'll talk about an example there. Before a developer goes and decides to purchase 160 acres, for example, they're going to go to the master plan, and they're going to look, and they're going to say, this is what's in the master plan. They've already put in a stream. They're calling for a stream corridor that needs to be preserved. Or they're calling for a regional detention facility in this location. Developers are going to want to know that. And it's important. So we're aiming to set that out and be transparent for the developers that are coming into the future. Again, I'm presenting sort of our Mile High Flood District, Denver metro area process. It's not the same everywhere, but it's been successful. And the first regional master plan that was done in the Denver area was done in the early 1970s. So they and we have been doing it for a while. Again, I'm fortunate enough to learn from the people that had to rack their brains to figure out how to get this to work 40 years ago, 50 years ago, I guess. The way it kind of works is you saw all those different municipalities, counties, towns, cities on the map, and any one of them can request a master plan, either an original master plan or an updated master plan at any time. And that's, again, the mill, Mile High Flood District is funded by a mill levy from all those cities and counties. So they go to the district and say, I'd like to, do a master plan on Buffalo Run tributary. I'm Commerce City. Okay, well, there's a lot of those requests that come in every year. There's only so much money, so it gets put on a list. It gets prioritized according to, funding and some other factors. And then there's obviously the co-sponsors that are involved. So, there's one example here, Lena Gulch, for example, that has Wheat Ridge as a requester and then 3 other co-sponsors because that tributary runs through all 4 municipalities. That means all 4 of these organizations need to come together and work on this master plan. And so then it becomes the district's really responsibility for managing that project and for funding it. I've taken specific names out of this, I know it's probably going to go up on the website and stuff, but the one thing that the district started doing a couple years ago, which I think everyone that's working there think is a great idea, is they've assigned specific project managers to each major watershed. It used to be that it was kind of ad hoc. You got a list of project managers, you got a list of projects. Bob is going to be finishing up his project, so he's going to take this project and run with it for the next 6 months or 9 months or whatever it is. And as you'll see, the results of these master plans are projects, capital improvement projects, and other things. And so it made sense that the person that was involved in managing the master plan also then manages the implementation of those projects down the road. And it's been a great modification by the district to do that because now Joe or Elizabeth or whoever who's managing knows all the projects that are going on. So if all of a sudden I get called in as a consultant to work on this regional detention basin and I have to run my models to do my design and whatnot, I go to the project manager and say, hey, did this detention basin up here ever get built? If not, when's it going to get built? Oh yeah, it's in construction, it's in design right now. Here's the specs on it. Put that into your model for your design. They know everything that's going on. So it's been a really good change, something to consider if you guys are doing similar wherever you work. So really the process is not, I don't know, it's a very engineering process, as you might imagine. We start out with models, hydrology and hydraulics models, and it's not easy to put those together by any means, but that's the basis for everything. That's the foundation. So we generate these models for existing conditions and future conditions, and from those models we identify the potential problems. Where does flooding exist? Yada yada, and I'll kind of go through what those are that we look for. And then once you identify problems, then you start looking at solutions. And you do an alternatives analysis where you start comparing the costs and the benefits of using this solution versus that solution. And the list here, again, a generally pretty engineered process depending on where you are and depending on the level of development that has occurred. So yeah, sometimes it's as simple as upsizing a pipe or upsizing a culvert. Put regional detention here, preserve this stream corridor there, and we'll kind of talk about why we might select one over the other. And then it is important to realize these master plans don't just get done and then put on the shelf and wait for the funding to come in. The funding is obviously always a concern, but these are updated, relatively frequently, or they can be updated frequently based on differences in, projections of population, land use. You guys are just like the Denver area, massive, explosive growth. Maybe the last time a master plan was done on, Clear Creek was 15 years ago. There was no projected population growth until 2040. Well, now all of a sudden it's here today. Okay, we need to update this master plan. So yeah, they can sit on the shelf for 15 years, but it doesn't mean that just once a master plan is done, it sits on the shelf. It can be updated and usually is. So the H&H, hydraulics, again, this is the foundation. And so, for the modelers in the room, you know what is involved here. We gotta, get land use information, soils information, precipitation, delineate watersheds. But really what we're trying to do is generate this graph that you see here on the right, which is, peak flow rates at different points along the drainage way. And, moving from left to right on the graph is upstream to downstream. And so it makes sense. As you move downstream, your peak flow rates for various events increase. And again, this is the foundation for what we are going to design our projects and our alternatives analysis around. We usually do this. It's pretty standard to do this for the 2-year through the 500 return period. And the other thing that goes along with the peak flow, which I'm showing here on this figure, are the water surface elevations, because we, of course, are interested in which areas are going to flood. It is important, I think it goes without saying, but it's important to understand what your planned future development is. Otherwise, Otherwise, we're just fixing the problems for now. So, most cities, counties have some sort of a growth strategy or a growth plan, whether it's zoning or land use data. By 2050, we expect this all to be commercial. By 2040, we expect this to be all low-density residential. The results of your master plan are only as good as what your plans for future development is, and that's part of the reason why they do have to be updated, as I kind of mentioned. Another very extensive part, and I am focusing a little bit on quite a bit on the H&H here, because it really is the foundation. You need to get it right. You go and you inventory all your bridges, all your culverts, all your stream sections, especially in an area that's already urbanized. And this is quite a bit of work. It's fun work. I like to go out and do it. But a certain master plan can have 100 different bridges and culverts, or 200 bridges and culverts, depending on how big your area is. That's also obviously a very important part of the process. And so we do all this, and we start running our models, and that gives us our ability to identify problem areas. A couple of examples are shown here. So we look at our stream crossings, and we see that a particular pedestrian bridge somewhere is going to overtop in the 10-year event and greater. Maybe that's fine. It's a pedestrian bridge, right? But what if that was a county road or some other facility that really shouldn't be overtopping? That's what the results of our analysis will provide us. The number of structures in the floodplain, that's huge, right? That's one of the basic objectives of doing this, is to remove structures from the floodplain. Identify major stream erosion and or potential erosion and mitigation areas, and then obviously different undersized infrastructure. So this is I think this is the fun part, I think, for some of us, which is now we need to start figuring out the best way to solve these problems. This is an example. I don't expect you to read all these, but this is an example of alternatives analysis for an area that you can tell is already highly urbanized. And so if you were to sit and go through these one by one, you would see, for example, that a lot of the solutions within the stream is grade control and channel grading. And the reason why is because we're already urbanized. We don't have room to reduce the flows coming off of the watershed and the subbasins. So we're basically limited to working within the channel and keeping that channel from blowing out and reducing the erosion. So, very quickly, your options become limited when you're working in an urban environment. Some of the other more common ones that you'll see up here is just replacing a small pipe with a large pipe. But if you can get out ahead of the problem and start doing master planning before there's been a lot of development in the watershed, you can start to do things like this, which is preserving the open space in the riparian corridors for where the floodplain is going to be and where the channel should be and will migrate. So this is just a map. You can see especially the green tributary further to the right. There is not very much development there at all. There's some major roadways and things like that, but there's not a whole lot of development there. So here is an opportunity to say, all right, we're going to set aside this channel corridor. That way we don't have to go in and fix pipes and put heavy armoring into the channel down the road. Let's preserve it. We'll have to do some modifications for the additional flows that are going to come, but ultimately the channel is going to be the solution. Clearly, this also gives you the opportunity to figure out where regional detention is going to be. If you can't just solve the problem in the channel, and a lot of times what can drive this is as you move your way down through the drainage way, you put flow requirements in along the way. So things are going to change. We think the development may be this, but it actually is this. But whatever happens upstream, somebody's responsible for putting in enough detention or modifying the development such that they can't exceed a certain flow rate at each of these flow locations. So this planned regional detention that I have shown here, kind of highlighted in the middle, this is a project that we worked on, and we were working with the developer on that site, and I knew what the peak flow was going to be upstream. Not right now, but I knew it was going to be in the future, and I had to design for the future. I also knew the peak flow rate that I had to meet immediately downstream of the site. So I had those two constraints to guide the design of that detention basin, according to the master plan. Real quick, so these are just some examples. A master plan that was done in the early 2000s, developed watershed, recognized that they needed to keep this area of open space available. It was 10 years later, but they went and finally completed it as a regional facility. And then same thing here, a regional plan that was done in the late 90s. Took a while, but ultimately, a real nice regional detention basin was built. I like this. It's, doing double duty. It really is driven by stormwater control, but you can see here it's a really nice open space. It attracts wildlife. There's trails running through it, so it's a multi-purpose facility. Okay, I want to get to the other main topic, which is, so I'm switching gears here. We'll have some time for questions. Full spectrum detention. We've talked a little bit about detention in this conference, and I guess I'll start with the table on the top is just a list of some other municipalities and what their flood control or detention requirements are. And you'll see it's very traditional, pretty much anywhere you go. It might be the 2-year, the 10-year, and the 100-year, or the 2-year and the 10-year, or the 10-year and the 100-year, or any combination of the two. And then, once again, we have Mile High Flood District. We have full spectrum, and then maximum 100-year are two constraints. So what is full spectrum? It does a lot of things, but I'll say that it's an approach. It's a detention design approach to minimize regional channel erosion. Again, our traditional detention objectives are that we have an undeveloped runoff hydrograph that looks like this. We develop the watershed, a hydrograph increases, most of us know this, higher peak. The whole point of detention is to bring that peak back down to the undeveloped condition. But I want you to look at these hydrographs and notice the peaks match pretty close. But once the water starts to drop off below the peak, you'll see that the runoff rate out of the detention basin remains higher than what it was in the undeveloped conditions. And so is that a problem? Here we have, let's consider this to be a large regional watershed of 50 subbasins, each of the exact same size. All right, so 50 100-acre basins, they're all the same size. And what I'm going to do is assume that I put the same detention basin at the outlet of each of those watersheds. I'm going to simulate what that looks like. And these particular detention basins are all sized with the criteria of meeting the pre-development 10-year and 100-year peak. So if I look at the discharge from one of those detention basins, that's what's shown here in this graph. And if I look at the 100-year, you can see that the red line, which is developed condition with the detention basin, matches the pre-development peak flow rate, the green line, at the 100-year level. Great, we're good. Same with the 10-year. Yellow, or the red line basically falls on top of the green line. We're good. All right. Now we'll look at the 2-year. Now all of a sudden the red line's quite a bit higher than the green line. It's not quite to the undeveloped, or it's not quite to the developed without detention blue line, but it's higher. So right away, okay, this might be a concern, and that's because what the 2-year, right, the 1 to 2 year storm event is generally, rule of thumb, what controls the size and the formation of our channels. Now what I'm going to do is go and do that same analysis at the very bottom of this watershed. So this is 50 times 100, 5,000 acre watershed, has 50 detention basins, all designed the same. Now I'm looking at the runoff rates at the very bottom. I'll go to the 100-year event. Red is higher than green. That means the peak flow rate is higher than the pre-development condition. We're not meeting our requirements or what we want. We go to the 10-year, red, again, higher than green, even the difference being much higher. And now we go to the 2-year. The 2-year, let's just use as a channel forming flow rate. We are almost the same as if we had no detention whatsoever in the entire watershed. We're almost at that blue line. So it's kind of a problem, right? We have 50 detention basins that we've built, and when we look down at the very bottom of the watershed, it's as if there's no detention, at least in the channel response perspective. So, Ben and Jim, who are obviously much smarter than me, came up with this. They started thinking about this. And the first thing they kind of figured out, they did some modeling, and they realized that the difference, the increase in runoff volume between pre-development conditions and post-development conditions is pretty much the same regardless of the size of the event, whether it's a 2-year event or 10-year event or 100-year event. The difference is the same for the same imperviousness of a watershed. So, for example, what I've circled here is an imperviousness, a site with 25% imperviousness. Developing that site with 25% imperviousness results in about 0.3 inches, watershed inches, of additional runoff from that site. That 0.3 is the same whether it's a 2-year event with 1.5 inches or whether it's a 100-year event with 3.5 inches. And the same can be said for other events. In this case, for 100% impervious, if I go from undeveloped to 100% impervious, I have about 1.3 inches of additional runoff. So that leads to, so they took that concept and they started playing with it and doing some modeling. And ultimately what they got to was that if we take what they call the EURV, the excess urban runoff volume, difference between pre and post-development runoff, let's capture that, and then let's slowly release it over the course of a couple days. And In this case, I'm jumping kind of to the conclusion, but right now the criteria say, at least in Colorado, 50 to 72 hours, something like that. Capture that 0.3 to 1.3 inches and hold it for 50 to 72 hours. And there's not a real physical or scientific reason other than you're trying to release that as slowly as possible to reduce the power, the stream power being delivered, the power being delivered to the stream. The 72 hours, this is a Colorado constraint. We can't capture and hold water for longer than 72 hours because of water rights. It's a very Colorado-specific requirement, but it's just something that we have to live with in Colorado because somebody else owns the water in Colorado. So they do that. We size for the EURV. We discharge that through an orifice plate, which is just a stainless steel plate with a bunch of holes punched into it. And that's the first level of control. And then we also add the 100-year pre-development condition, actually 90% of the pre-development peak flow on as the other control. So most other places, they may control for the 2-year, and then the 5-year, and then the 10-year, and then the 100-year. And you end up with these outlet structures with holes and rectangles and all these different shapes to try to control each of these different ones. And it's a tough design. This is a very easy design for an engineer to do. They have a spreadsheet that almost does it for you, and it's very effective. So here's the results now. If I take that analysis that I showed at the bottom of the watershed. Now I've applied a full spectrum detention to each of those 50 sub-basins. And now instead of looking at the red line, I want you to look at the gray line, which is developed with full spectrum detention. The gray line compared to the pre-development green line. Of course, for the 100-year, we're almost the same. 10-year, we're almost the same. And importantly, the 2-year, the erosion storm, we're pretty much the same. So that's where I'm kind of saying that this is a design that protects against channel erosion, protects against the peak stacking, which is what causes this. When you have tens or dozens of detention basins in one watershed, the peak stacking is what causes the effectiveness to be diminished. And probably most importantly, because this is a question that always comes up, is, well, yeah, but how much bigger is your facility? It's really not. It's not any bigger than if you were to do a traditional 10-year and 100-year. And the reason why? It's the 100-year event that drives the size of your basin. So whatever we're doing underneath that, it really doesn't change the volume that much. So I'll preface that before I jump to my last topic. All those numbers obviously are very specific to Colorado, but I think the concept, if you followed the same process, my guess is that the concept would apply anywhere. So this is just kind of lessons learned, open discussion of a lot of the work that we've done on green infrastructure over, probably over about the last 15 years, at least myself. And what I'm referring to here, as I talk about this, is really the permeable pavement, bioretention cell type of capture, retain, infiltrate systems that I think most people generally think about as green infrastructure. So I really got involved in green infrastructure, like I said, about 15 years ago. I moved to Fort Collins, went to Colorado State University for my master's and PhD, and I got involved with green infrastructure right away. It was perfect timing because the city had started hearing about this green infrastructure, low-impact development stuff, And the professor I was working with at CSU was, they approached him and said, you're a stormwater guy, help us with this, help us understand what this is. We think it's something we want to do. So he got some grants and some funding and hired me and some other graduate students to, the first step was to build some pilot projects and monitor them. As you might imagine, City Council was interested in the concept, but they certainly didn't want to go and mandate and require these new technologies without some proof that they actually worked in the city. At that point, a lot of the research was coming out of the coasts, East Coast and West Coast, and okay, that's great. It also rains 40 inches a year versus 15 inches a year in Colorado. Let's see if these things work. So we started off by doing a lot of monitoring, permeable pavement systems, rain gardens, et cetera, and the point there being that it was the monitoring that we did that really proved the performance to the city. We said, look, hey, here's the data. Yes, they capture water, number one. Yes, the runoff volume is reduced. We're getting water to infiltrate. We have the data to support that. We're getting some pollutant removal too. The water that does go through the under drain, the concentrations are less. Great. Not easy, not cheap, but you need to have that, especially for the council members. And then, over time, we continue to monitor, and we still monitor. I still do monitoring projects at Wright Water today. I did one in Vail all summer long. We've been doing them in Denver for several years, monitoring different things. And really the idea there, again, proof of performance, but a lot of the monitoring that we've done, along with a lot of monitoring that the district has done, has led to design improvements. So we could sit down, we're engineers, we design this thing, yep, it's gonna work perfect, this is how much is gonna happen. We go and actually put instruments on it. Well, wait a second, how come that doesn't seem right? Number one, we have to monitor for long enough to make sure that what we're seeing is real. But then you make modifications. Well, let's try a different under drain size, or let's try different filter material, or let's try a different orifice plate configuration. And a lot of these design improvements are driven by the real world data. So if you are going to go down that road, monitoring is not cheap. It's very difficult. You have to do it for many years, multiple years, but it truly is worth the investment. The other thing in Fort Collins so eventually all this went through, and in Fort Collins, we now require these infiltration-based practices on all new development or redevelopment to a certain extent. I'm not going to go into what those requirements are, but there's a lot of green infrastructure that's gone in the last 10 years. As it started going in, I was fortunate enough to be able to, whenever a new project was being designed, the city would let me know, and they said, hey, we got a new permeable pavement system going in, we got a new bioretention cell going in, et cetera. And as soon as that thing was built, I'd go out every time it rained, I'd go and see how it was working. And as you might expect, I didn't always have the best news to report back to the city. I'd say, hey, I was out there and, there's no water getting in this thing. Or, there's water getting in it, it's just sitting there, it's not going anywhere. And, you name it. And we start diagnosing it, and it was either flaws in the design or flaws in the construction or a combination of both. And really, it made perfect sense. The engineers that were designing it, the contractors that were building it, had never worked with this stuff before. If you think about a contractor, all their career, they've always made water flow downhill somewhere into something. You don't let water just stand and pond somewhere. Well, that's what we're trying to do now. And so even if the drawings would show, hey, the invert of this should be this high so that the water sits there in ponds. The contractor thinks, that's not right. I know it's got to be down like this because the water's got to flow out. So the long and short of that was we ended up implementing a checklist, an inspection checklist. Somebody from the city now goes out on each one of these new projects, and they go out at multiple times because you've seen some of the cross sections. We have a filter media, we have an under drain, we may have a liner underneath that. Well, if you go out at the end of the project, you have no idea what the under drain looks like, you have no idea what the liner looks like. So they have to go out, as you can see here, subsurface inspection, surface inspection, pre-construction meeting. Let's make sure you guys understand this isn't what we traditionally do or what you're used to. It's been enough years now where this is becoming less of an issue because the contractors are building this day in and day out. They've been putting permeable pavement in for 6, 7, 8, 9 years now. But anyways, that was a lesson learned. And then finally, I know a lot of people have really hit on this, but it really can't be emphasized enough. It's the maintenance. One of the things that I also did when I was at CSU as part of the Stormwater Center, other cities would invite me in to kind of talk about maintenance, and then they would always take me on a tour of their facilities, and there was rarely a facility that I went to that did not need some type of maintenance. Like somebody mentioned this morning, I can't remember which one, 50 to 70, I think it was Mark in Nashville, 50 to 75% of the inspections come back with something needs to be done. Yeah, absolutely. The cities can only control so much. They can control the facilities that they own. That's fine, but make sure that at least those facilities that you own, you can maintain. It's not rocket science. It just, there needs to be a schedule for it. Somebody needs to be taught how to do it, and that's it. It's no different than cleaning out an inlet like you do every fall or every spring, cleaning out a culvert like you might do every few years, whatever it is. So I left a few minutes.
Thanks, Chris. Questions for Chris? Full spectrum detention. Yes, come on up.
I think I understood you to say you don't own the water in Colorado. Who does?
I wish I owned water because I would probably be able to sell it and not be here right now. But no, people do own the water. Various people own the water. What I should have continued with is that the water that falls on your property, the water that falls on my home or my driveway, I cannot legally take and use that water because somebody else owns it. Somebody downstream owns it. And so the idea that we can just capture water in a detention basin and sit and hold it there for days and days and days has the potential, if you multiply that by hundreds and thousands of detention basins, has the potential to injure somebody downstream. In other words, they don't get their water that they're supposed to have. It's a water rights, it's a Western water rights issue. But it's a significant constraint that affects us where a lot of places, the Walmart project that we saw this morning with Opti and being able to control and things like that, we could never do that in Colorado. We can do LID, we can do bioswales and bioretention, we just have to make sure they're emptied within 72 hours.
Colorado water rights are a dissertation in themselves, I imagine.
Yeah, I am far from an expert in that. That's the other half of our company.
Stephen.
Hey, Chris, great presentation. The EURV, y'all are using that in the Denver metro area? It's being regulated to that? Or it's written into your criteria?
It's pretty much been adopted by most of the Denver municipalities. Yeah.
Are there areas outside of Denver that have began adopting that design philosophy?
There are various areas, I would say on the Front Range, north and south of Denver that are not maybe, a couple hours from Denver. I think that's pretty much it, though. I don't know of anybody outside the state.
Okay. So it seems like a great concept.
Yeah. Well, and again, I'm only reporting it. I don't take credit for developing it.
Other?
So I know for a lot of our state conservation agencies in Arkansas, there's been a big emphasis the past several years on removing barriers to fish passage and stream connectivity. And so I'm just thinking about some of the images you put up there of big regional detention, and two questions are, one, in your previous experience, are you building any of those sort of on live streams, or are they off the stream channel? And two, if they are there provisions made for fish passage? Is that somewhere that the industry is going or thinking about right now?
Yeah, no, that's a really good question. I guess the answer to the first, are we building these online? Yeah, in some instances. Actually, the example that I showed you, we ended up doing that one offline not for fish reasons, but for other reasons. But what I would say is that the vast majority of the streams that you saw on that map that I showed you going east from the foothills through Denver, I don't think anybody would consider 90% of them to be, fishable not from a health perspective. They're small, and a lot of them are dry half the year. So fish passage in that area and online detention has not really been an issue, I would say, at this point. Fish passage up in the mountains on those streams where, cold water trout and all that, completely different. There's also not the development to be putting large regional detention on a stream. So, great question. I don't think it's really come up. Yeah.
Meredith.
You mentioned that you've been doing more and more green infrastructure over the decade or so, and I'm curious if that has corresponded with the cities actually writing that into their codes and how the development community has responded. Mm-hmm. And it seems like even though there's a lot of ecological conditions that are different, the rapid development, I think, is similar. So I'm curious, not only in, some of the city centers, but some of the suburban communities as well.
Yeah, great question. Fort Collins, again, where I live and where this really started, I shouldn't say they started in the state, but they did end up putting into the criteria in the code, so they have to use these practices. There are some opportunities for variances, but for the most part. And the others, I don't know others that have put it in as a specific requirement, but there's definitely been a lot of incentives actually driven by the state, by the Department of Public Health and Environment, which regulates the MS4 permit. I had a slide that I actually took out. There's now a provision in there that you can capture less water on a new development if you infiltrate it. So I think Carol might have had kind of something similar to that in her presentation. But basically, you have a development, you have to capture and detain X amount of water for that development. If you've designed it to fully infiltrate, you only have to capture 60% of it. And that's been an incentive only recently put in the MS4 permits that have been driving it. And then other municipalities have put in kind of somewhat similar, or prior to CDPHE putting in the MS4 permits, the other local municipalities were doing similar incentives to promote it. Fort Collins is the only one that I know of that requires it regardless.
Chris, what's your response on that one? Just kind of brought up one thing to me. If your downstream water users have ownership of those rights, how do you get away with infiltration on your site? Or what does that do in that conversation?
Yeah, that was decisions made by state engineer's office, and I mean, as they were going through all this, they basically, kind of came to the conclusion that the word is de minimis. We're capturing a tiny, small amount of water. We're infiltrating it. It's not going to have that significant of event. The amount of water, so our water quality capture volume is a half an inch. So half an inch of runoff, right? Yeah. They said, okay, that's fine. You can infiltrate that, no big deal. It's all tributary anyways, it's gonna get back. Where they were really concerned were like the big regional that are gonna capture 100 acre feet of water during a particular event and hold that water back. 100 acre feet in certain streams is actually, pretty obviously significant. So, yeah, that was, people way above my pay grade had to figure that out. All right.
Any
Thanks,
other
everyone.
questions?
I'll be available if you have more questions, or you can email me.
Thank you, Chris.